Hi guys, so today we are going to be starting chapter 6. In section 1, it is all about zero and negative exponents. So whenever we have a zero as an exponent, so that's saying if we have any number, so 2 to the 0 power, 527 to the 0 power, anything like that to the 0 power, our answer is just 1. The only time that this does not work is if we have 0 to the 0 power. In that case, it would be undefined. But for any other number, letter, no matter what, anything to the 0 power is just 1. And then we have the idea of a negative exponent. So this says for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. So that gets a little confusing because you've got a lot of letters going on in there. But a is just a number. So imagine that as like 2, 5, 17. And then same for n. That can be any number. 2, 3, 4. But with negative exponents, the big thing to remember is we cannot have negative exponents in our final answer. So what we're going to do is we're going to work through a few examples with negative exponents to show how we make those positive. All right, so our first one, we have 9 to the negative 2. We cannot have negative exponents, so we have to fix this. Remember that whole numbers are always over this imaginary 1. Every single time, they're always over this imaginary 1. In order to make your exponents positive, you need to move them either to the bottom or in some cases to the top of your fraction. So in this case, 9 to the negative 2, that is a negative exponent. So we have to move this whole piece to the bottom of our fraction. So that means now up top we just have 1 because the 9 squared got moved. And the 9 squared goes on bottom. Since we moved it to the bottom of our fraction, our exponent now became positive. And then the last step we have to do is just simplify that. So 1 over 9 squared, 1 just stays the same, but 9 squared is 81. All right, for our second one, we have something very similar. We have 4 to the negative third. Remember, again, this is over that imaginary 1. In order to make this piece positive, we have to move it to the bottom. So now up top, we just have 1. And now that we've moved this to the bottom, our exponent becomes positive. And then our last step is just to simplify 1 over 4 to the third. So we just do 4 to the third. Remember that is 4 times 4 times 4, which gives us 64. For number 3, we have negative 5 to the 0 power. Remember, anything to the 0 power is just 1. Does not matter that it was negative 5 in there. That 0 just makes it a 1. You can test this in your calculator, and it will give you the same answer. Again, for number 4, we have 6 to the negative 1. I always just like to make mine look like a fraction. It just helps me to kind of get the concept of moving my negative exponent to the bottom. So again, this negative, in order to make it positive, we have to move it down. So up top, we are just left with 1. And now on the bottom, we have 6 to the first power. You can just leave that as a 6, or you can put that 1 for the exponent. That's fine either way. And then for number 5, we have negative 4 to the negative 2 power. Negative 4 is in parentheses. This is very important because that means we are doing negative 4 times negative 4. We just need to be really cautious with that and make sure that we are in parentheses when we do this. So again, we have this negative exponent, so it's going to have to get moved to the bottom. So up top, we are just left with 1. And then on the bottom, we have negative 4 squared. So our exponent turned positive since it got moved down. And then again, whenever we are putting this in our calculator, so this is negative 4 squared, that means we are doing negative 4 times negative 4. If you just plug negative 4 squared into your calculator without those parentheses, it will give you the wrong answer. In this case, negative 4 times negative 4 is a positive 16. So just be really careful with that one whenever you go to plug it in. Okay, so we have gone over just the main idea of simplifying the powers. Well, now we are going to simplify expressions. So we might have multiple pieces, but not everything has to move, whereas in these previous examples, everything has had to move. So for number 6, we have 5a to the third, b to the negative second. It is very important to take note that these exponents only apply to what they are directly connected to. So for this first one, this piece here is the only one that has a negative exponent. So again, keeping in mind this is all over 1, but this b has to go to the bottom while everything else stays up top. 5 doesn't have a negative exponent. A doesn't have a negative exponent. So 5a to the third will stay up top, but that b to the second will have to come down to make our exponent positive. Number 7 is kind of similar to what we did above, except instead of dealing with a number, we now have a letter. But we have x to the negative 9th. Again, just remember, whole numbers, whole expressions, they are always over this imaginary 1. So in order to make that exponent positive, we have to move the whole thing to the bottom. So now the only thing that's left up top is just 1. And then on the bottom, we have x to the 9th. Do not drop off that exponent because remember, x is a number. It's some number. We don't know what it is. So if you drop off that 9, then it's going to change the whole answer completely. So even though it's a variable, you still have to keep that exponent number with it. In number 8, we have 1 over n to the negative third. So this one is slightly different than what we've done in all of our previous ones. Notice that our negative exponent is in the bottom. So now, in order to make it positive, we actually have to move it up top. So we are left with n cubed over 1 or just n cubed. Both are perfectly acceptable. Number 9, we have 4c to the negative third b. Again, I just like to always put these boxes around my negative exponent pieces. It helps me kind of see what has to move and what doesn't. So if this whole thing is over 1, the only negative exponent we have is this negative 3, and that's only attached to c. So that is the only piece that has to move down. The 4 and the b get to stay up top. And then on bottom, we have c to the third. And then for number 10, we have n to the negative fifth over m squared. Again, the only negative exponent we have is this negative 5, so this n to the negative fifth. So that guy has to get moved down. So now we have nothing left up top, we just have this 1. And then on bottom, we still have m squared because it was positive, so it stays where it's at. And then n to the fifth, and that 5 becomes positive since we moved it to the bottom. You could also write that as n to the fifth, m to the second. Both ways, perfectly fine. Multiplication can be flipped around that way. All right, so now we are going to move into evaluating expressions. So we have to do like we were just doing. We kind of have to simplify first, make sure everything has positive exponents, but then we have to plug in numbers. So it says, what is the value of 3s to the third t to the negative second for s equals 2 and t equals negative 3? So first thing that we're going to do is we are going to look at this expression that they gave us. Notice that we have a negative exponent. So very first thing that we're going to do is we're going to fix this expression so that we don't have negative exponents. So let me rewrite it over here. 3s to the third t to the negative second. Remember, this is over that imaginary 1, and we need to make this guy positive. So in order to make that exponent positive, we just have to move t to the negative 2 to the bottom. So we have 3s to the third over t squared. So now we have all positive exponents, and now we can work with this information that they gave us. They told us s is 2 and t is negative 3. So we have 3, times 2 to the third over negative 3 squared. And now we need to simplify. Remember, with PEMDAS, we do parentheses. We don't really have any parentheses to work with. And then exponents. So we need to do 2 to the third power first. So we still have this 3 up top. 2 to the third power, that's 2 times 2, which is 4. 4 times 2 is 8. And then on the bottom, we have negative 3 squared, which is positive 9. And our last step, we have to do 3 times 8, which gives us 24. And on the bottom, we still have 9. Okay, and the next one, so it says, what is the value of 1 over nw to the negative 1 for n equals negative 2 and w equals 5? So again, notice that we have this negative exponent here. First thing I want to do is make my expression have all positive exponents. So I'm going to move just that piece to the top. So that gives me w over n. Again, remember, you can put that one exponent, but you do not have to. And then I'm going to plug in the information that they gave us, where n is negative 2 and w is 5. And then that just happens to give us our answer because there's nothing else for us to do there. So we just have negative 5 over 2 or 5 over negative 2. Same idea. For the next topic, we are going to go over multiplying with the same bases. So if you have two numbers that you're multiplying together, they have the same base, then you will add their exponents. So same base means that it's the same number with a different exponent. Sometimes it has the same exponent. And then you will just add those together. So for 13, we have 12 to the fourth times 12 to the third. These 12s are our bases. So it's the main number that you see. So since we have the same base, then we can just add those exponents together. So 12, and then we do 4 plus 3. You do not do anything with combining those 12s. Since they're the same, you just use 12 as your base again. So don't try to do 12 plus 12 or 12 times 12. You just rewrite 12 as your base, and then you worry about your exponents. So we add those together, and we get 12 to the 7th. These directions said, what is each expression written using only one base? So we do not have to solve these. We just had to rewrite it as a 1 base with an exponent. So for number 14, again, we have 9 to the negative 3, 9 squared, and 9 to the 6th. All of those have the same bases, so that means we just pull that base over of 9. And then we add all of those exponents together. Negative 3 plus 2 plus 6. And that gives us 5. So then our final answer using only 1 base is 9 to the 5th. And last one like this, we have 0.5 to the negative 3rd and 0.5 to the negative 8. So those bases are the same. So we have 0.5 and we add those exponents. So we have negative 3 plus negative 8, which gives us negative 11. So we have this negative exponent. We know we can't have that. Remember, this is over that imaginary 1. So to make this piece positive, we have to move it into the bottom. So that gives us 1 over 0.5 to the 11th power. And last thing that we have to cover is multiplying powers in algebraic expressions. So again, kind of combining everything that we've gone over so far, you have to simplify these expressions, combining the bases if you can, and multiplying numbers, trying to make it just look a little bit smaller. So for number 16, we have 4x to the 5th times 9z to the negative 12th. So first thing, notice that we have a 4 and a 9. We're multiplying. So first thing that we want to look for is those numbers, and we want to go ahead and combine those. So we want to do 4 times 9. 4 times 9 is 36. Okay, so we've dealt with the numbers. The numbers no longer need to be seen, used, they're gone. And then what's left is x to the 5th and z to the negative 12th. So now we want to look and see if we have any common bases, to which we do not. So then at this point, we just bring everything down. But now we notice that we have this negative exponent. So remember, if this is over that imaginary 1, in order to make that exponent positive, it has to get moved down. So up top, we just have that 36x to the 5th. And then on bottom, we will have z to the 12th. All right, number 17. We have 2a times 9b to the 4th plus 3a squared. Again, very first step, notice all of these constant numbers out front. We're multiplying still, so we have to do 2 times 9 times 3. 2 times 9 is 18. 18 times 3 gives us 54. Next, we want to look and see if we have any common bases. Well, notice we have a and a squared. So we have a common base. This a has this imaginary 1 exponent. So following what we did above, a to the first power times a to the second power would be a to the 3rd, because we just add those exponents. And then we just have b to the 4th left by itself, so we just tack that on at the end. And last one, negative 4c to the 3rd times 7d squared times 2c to the negative 2nd. Very first thing again, multiply all of those constants. Negative 4 times 7 is negative 28. Negative 28 times 2 is negative 56. We look for our common bases if we have any, and we do have c to the 3rd and c to the negative second. If we combine those like we did above by adding those exponents, 3 plus negative 2 is just 1, so it's just c. And then we have d squared, nothing to combine that with, so it just stays tacked on there at the end. It is very important to note as well that 56 is negative, and that's okay. We do not have to move that into the denominator. We only do that with negative exponents. Negative whole numbers, totally fine. We do not have to move those. All right, and that is all for your notes on 6.1.